Here's chapter 4a, example 7. We're looking at confidence intervals for quantitative or numerical data. So in the 2009 holiday retail season, they wanted to analyze the 2008 data. So here is some self-reported consumer data from 2008. This is a histogram made up of 436 randomly sampled American adults data about their average daily consumer spending during the holiday season that starts right after Thanksgiving. Economists use holiday season shopping as a way to measure if we're in a recession or in a more robust economy. So you can think back in 2008 was the beginning of the recession. So here we're told the daily consumer spending averaged $84.71. That's our sample mean. And the standard error was $2.20. So we can use the total sample standard deviation to calculate the standard error. So we've got 436 people. Here's our sample data. It's skewed to the right. It's okay to have the histogram skewed to the right because we know long term, if we sample enough, we expect normal results. So we want to estimate the true population average daily consumer spending for 2008 using a 90% confidence interval. So our sample mean of 84.71 is over here between 50 and 100. That looks like a reasonable center of this distribution. It's also okay to use a slightly skewed distribution because our sample is so big, right? Since we've got 436 people, I'd be more worried if we had a smaller sample of 20 or 30 people in a skewed distribution, but since our sample is large, we know that a little bit of skew is gonna make our data okay. So our 90% confidence interval, we're going to start with the sample mean as our center, and then we're going to extend out. We want 90% confidence, so we use the corresponding z-score, 1.645, and then we're going to put our sample standard deviation, which is our standard error in here. So we've got 84.71 plus or minus 1.645 times 220. When you multiply this, you get 3.619, and then we get our lower bound is 81.091 when you figure out 84.71 minus the 3.619, and then when you add, you get the 88.329 as our upper bound. So we can interpret this by saying with 90% confidence in our methods, we predict that the population mean for daily spending is between $81.09 up to $88.33. So remember, when we make a prediction, we always want to give a range, not a single value. If we just give a point estimate, we're probably wrong. If we give a range here, we've got a much better chance of being right. In this case, for part A, we are 90% sure that we're right because we're 90% confident in our calculation. So now we want to give a 99% confidence interval. So we're going to up our confidence, which means we need to up the range of our interval. So notice our calculation is almost the same. The difference here is that we've changed our count of standard deviations. So 99% confidence corresponds with 2.576 standard deviations. This is our z-score right here. So when we multiply 2.576 by our standard error of 220, we get 5.6672. Remember, the standard error is like the standard deviation associated with an estimate. So since we're making an estimate, we're thinking about this is a standard error. When we've multiplied our z-score by our standard error, this 5.6672 is our margin of error. So this is what we're going to add and subtract from our sample value. Notice the center doesn't change. So when we were 90% confident, we still started with the $84.71 as our sample mean, and that doesn't change when we up our confidence. So our interval is still centered in the same place. The difference is that our interval gets wider, so we're adding and subtracting a wider range to have a wider margin of error. So when we add and subtract, our lower bound is $79.04, and our upper bound is $90.38. So we can say with 99% confidence in our methods, we are predicting the population mean for daily spending is between $79.04 up to $90.38. So when we write a statement about our confidence interval interpretation, we want to make sure we're reporting how confident we are, and that's confidence in our methods or in our calculations. We want to make sure that we explain that our prediction is about the population mean. And then we want to make sure that we've explained the lower bound and the upper bound, because we don't want to give just one value as a point estimate. We want to give a range of values.